Okay, this video is on how to set up a matrices and solve torques and moments, and maybe you have a problem that's complicated and you're concerned that maybe you're going to forget a force or forget a distance or something like that. What you can do with this would be you can set up a matrices, and I've come down here and I have something set up here. Torques is going to be the cross product of R cross product F. Moment is the cross product of R cross product F. Now R is the distance. So what we would do here, you'd let this point be your 0, 0, and you'd say how far away are the forces. So we're going to do this first. So here you have 8 coming back this way, so that'd be -8. So we'd come down here, we'd put a -8 into here, like this. We go to J. We say, well, how far are the J values? Are we going up? No, we're not at all, right? J in this case would be 0 in all cases, right? Because they're in the same plane. If I cut a plane through here, there's no value. So I put 0 into here. I go to my K distance and I say, how far is K going to be? K is going to be +3. So I put that into here. I go to my forces and I say, which ones are going along the x-axis? Well, I have this one. It's going negative, so I make that -75. I come to my y value and I say which one is going along the y. Well, I have 80 going down. I go to my k force and I say which one are going along the z-axis. Well, 100 is going positive. Okay, so all we now have to do is just solve this and get this out of the way, and this is actually pretty easy. Because now we can say that our torques and moments, whatever you want to say, torques and moments is going to equal to, we start with the I. I'll put the I into here. And now, remember this, we're going to do this times this minus this times this. This times this is 100. That gives me minus, so I'm subtracting, a minus 240. That gives me 240I. There. So now you're done with this one. Now remember, when you go to J, you got to go minus J, because this goes plus minus plus. When you go to J, we go -8 times 100 and minus, so we got this times this, -3 times 75. That's -75. Okay, then you go to the Z, or the K, plus K. We look at this column. That'll be -8 times 80. Sorry, -8 times -80 minus 0. So we can just forget about that. 0 times 75. Alright, so now we can do this, and then we can know our torques and moments are going to equal to 240I. That gives me -8 times 800. I'll get a calculator for that too. So that gives me a -800 minus 3 times -75. That gives me -75, so that gives me plus 575J. Value here, I'm going to do this one here. I get 8 times 80. Again, those are both minus. That gives me plus 640K. Okay, so that if you do it this way, you really cannot make a mistake. It's too easy. Again, if it's fairly complicated, it's really quite easy to make a mistake. So now I come up to here. See if I can grab this value. I edit. I copy that. I'll bring it up to here. We'll paste this into here. Bring this value into here. I'll put it right here for right now. Okay, then label your axes here. This would be positive J. This is going to be positive X, and I'll put positive here. X positive here. This is your K positive here. Here you got 240I. Again, use right hand rule thumb goes down the x-axis, so that means you're going to get 240 going this way here. Phi 75J, right-hand rule again. Phi 75 is going along the y-axis here, and let's see, phi 75, so that's going to go back this way here, right-hand rule. I do the 640 times k, right-hand rule again here, and this is kind of hard. It's okay. Now it goes this way, and that's it. If you do it this way, you cannot make a mistake. So then when you look at it, you say, well, this value, this has to be my torque. These are going to cause bending moments, and this is going to cause bending moments. And that's a good way to do it. I hope that video helps you.